Example 5. Write a sine and cosine function to model the graph below. So in this situation, instead of you giving me a graph, I'm giving you a graph and asking you to write a sine and cosine function to model it. We're going to begin in exactly the same spot that we did before. In other words, we're going to identify things like the period and the amplitude and the midline. So let's take a look at this one. I see that my highest value looks like it's here. What value is that? Looks like I'm at 3. And my lowest value is here going through -1. -1. So halfway between 3 and -1 would put me at +1. All right, so I have a midline of y equals 1. I think that's what I said, +1. And I have an amplitude of 2. And what is the period of this function? The period of this function, where am I seeing it repeat? I'm seeing at 0 that it's hitting its lowest point, and I don't see that again until I hit 6. So it looks like the period is 6. All right, but remember, the period being 6 is not what I'm going to use in my equation. What I'm going to use in my sine and cosine function, that 6 is equal to 2 pi over b. So if I cross multiply, I'll get 6b equals 2 pi. So b is going to be 2 pi divided by 6, or pi over 3. All right, so do we want to start with sine or cosine? You know, it doesn't really matter which one we start with. To me, this looks like a pretty nice cosine function. We're used to cosine functions at 0 being at their highest value. This one's at its lowest value. So I'm going to say that the cosine function would be negative something, negative that amplitude, which is 2, times the cosine of my b value, which is pi over 3x, and then my midline, that is 1. So I'd encourage you to type that into your graphing device and see if it matches. I could also try a couple of different values to substitute in to see if they work. For example, on this picture, I can see that this point right here is the point 4, 2. So that means that if I were to put in f of 4, I should get an output of 2. Let's see if that works. And I'm going to run out of room, but let's see. -2 times the cosine of 4 pi over 3 plus 1. So what's the cosine of 4 pi over 3? I think that that is -1/2. So -2 times -1/2 plus 1 is going to give me 1 plus 1, or 2. So it checks. All right, now how about, let me work in green for this next one, or green, there we go. And let's see, g of x I'll call, and that will be my sine curve. Now a normal sine curve at 0 hits its midline. Now we're not seeing that midline hit until right here. So there's been a shift involved. In fact, if this is 1, then this must be 1.5. So 1, and that's 1.5. I'll call it 3/2. So our normal sine curve got shifted to the right by 1.5. Now that's one thing I didn't write down. I should probably write down that we have a horizontal shift of 3/2. All right, so I'm going to say that g of x is equal to my amplitude, not reflected, times the sine of my b value, parenthesis, x minus 3/2. Now it's minus 3/2 because I want to shift it to the right 3/2. And then on the end, I am going to have my midline. And what did I say that was? I said that was equal to 1. And again, we should maybe test that out. Let's use that same point and see if it works. I don't know if that's an ugly point or not. Maybe let's try something easier to compute. How about 0? Oh, let's just do the same one. We can do it. If I substitute 4 in, I'm going to get 2 times the sine of pi over 3. 4 minus 3/2. Oof, I'm not going to have enough room, am I? What is 4 minus 3/2? Well, 4 is 8/2, so I get 5/2. I think I'll just put this into my calculator since I'm running out of room. Go ahead and stop the video for a second. Substitute that into your calculator. Make sure that you're in radians. And I think, I'm pretty confident, you're going to get an answer of 2. If you have any questions, there's been a lot of videos on this one. If you have any questions, make sure you email me or post to the corkboard.